Math team, diamonds and digits. Taking a look at rational numbers. The whole unit, we're starting it up. Anyways, welcome to Math 9 in the PM. Olsen Document Report. What is a rational number? Well, rational number is any number that can be written as a fraction. The bottom number, the denominator is the word we use for that, of a fraction can never be zero. The top can, the numerator can. You guys used the word numerator, denominator in previous years? Okay. Top and bottom, we can use those as well, but if your teacher says numerator, I hope you know it's the top, denominator is the bottom. Okay? You have to be able to communicate math ideas, that's all. Show that each number is a rational number, and we're going to work through some of these together. So the first one, 7 is not a fraction the way it's written, but you can make it a fraction. The easiest way to make any whole number a fraction is to say divide by 1. Or fraction, oh wait, I just said divide by 1. Any fraction can be thought of as a division problem. You guys were aware of that, right? You can put it into your calculator or you can do it in your head. Well, the easiest number to divide by in my head is 1. So show that this is a possible rational number. I'm going to do it just what you said. 7 over 1. Hey, it's a rational. It's like a rational number. It's a fraction. You could have put 14 over 2, but I mean, why be more complicated? 14 over 2 is also 7. I'm going to just get a sheet here. Yeah, I don't even know the answers by now. It's good. I'm mentioning something here. All decimals that terminate are rationals. It has a last digit. That's what it means. And we're going to do this one right here. You guys remember? I'll write this down and then you're going to have an answer here. If you want to come up with an answer and show it sort of even with a baby. I'm going to don't repeat it because I want to see if other people get it. You're right. Jot this down and then we'll talk about it. Okay. I'm going to go back to elementary school. I'm not literally. Go back thinking to elementary school. You know how we reviewed our place value names, position names, head of the decimal, times, thousands, and stuff like that. What is, anyone but I know this person. Anyone else? What is this position called? The first one after the decimal. Tenths. T-E-N, tenth, with a T-H-S at the end. You know why? It's because anything that ends in that position can be written as a fraction out of 10. That's 3/10. If it was ending in the hundredths position, I'll erase that. If it was this, 0.35, I would say that that's 35 out of, it's a hundredths position, so out of 100, 35 hundredths. If it was this, 007 is 1. As a fraction, though, what's 007? Decimal. Yeah. Nope. 7 out of what position is that in? Thousand. So out of 1,000. But there's other ways. Some do. Like you can reduce this 35 out of 100, but I mean, that's probably what you're getting at. You can't reduce things, but you're guaranteed that that's a proper, it's an actual fraction. It's not always in the lowest terms. You guys remember the word lowest terms, right? You can't. Because 35 and 100 both have 5 divisible. Okay. But I'm not even worried about that. I'm just saying get that, and I'll expect to see if you can reduce it at the difference. Keep the one still in. Thank you. Okay. So if it terminates, not all of them terminate. Oh, here's one, and this is a good example. I'm going to say, okay, according to what I just told you, though, what could you automatically, without thinking, call it? If you see this on a price, what would you say? quarter. So what is a quarter as a fraction? 1 out of 4. You guys are aware of this? This is just common. Like, if I see 0.25, that's a quarter of the coin, right? Why? Because that's 25 parts out of 100 cents out of $1. Now, if this had nothing to do with math, and I know you know, so I'm not going to ask you. So if it's, what math would I do to divide? What math would I do to reduce this so that I get 1 out of 4? Remind me, someone else. Yeah. 25 divided by 25 is 1. 100 divided by 25 is 4. If you can see the same number that goes into the top and the bottom, now I'm not using math, we're going to do now top and bottom, then you can reduce it by that amount, by dividing. And that's exactly what Charlotte was getting on. Okay. What about decimals that have repeating patterns? So this one, there's a way to do these. If you were just given decimal 333 repeating, it is 1/3. I'm giving you that because today I'm not expecting you to know how to get 1 out of 3. Some of them you might just know from memory, like decimal 666 is 2 out of 3. But if I gave you a pattern, and maybe, I don't know, hunch that there's somebody who might know this. If I gave you this, 0.1, 1, 1, and continue that pattern, would you know how to get that to a fraction, Chuck? Not sure? You're not telling me. You'd have to figure it out. There's a way to figure it out, but we're not worried about that right now. I don't want to get too ahead of us. Just wondering, because you seem to have a real, pretty nifty with numbers. Okay. All decimals that have repeats are rational numbers if it's a repeating path. Then what isn't a rational number? They're called irrational numbers. You were going to say? Yeah. There's some square roots that aren't rational numbers. Those are the ones that come up the most in grade 9 and in high school. All mixed numbers are definitely rational numbers. Just to review those, you guys know improper fractions, how to go back and forth, right? I'm seeing some nods, but if you don't, let's talk about math. Very bad at fractions. Okay. You think you can get better? Yeah. I think so too. It's my job to help you get better. I really don't care if you were bad before. It just means I have to work for my money this semester. I don't mind if you weren't. Actually, you'd be wasting your time if you knew everything ahead of time. So on D and E, just to clarify, someone asked, there's nothing to answer. Those are just examples where I give the fraction. They're all rational number examples. Irrational numbers are not, and they're things like pi or some square root of 2. It's not a nice number. Square root of 4, do you guys know square roots? Square root of 4 is 2 times 2, it's 2, right? Square root of 9 is 3. So then can you think of a number that multiplies to give you 7? Yeah, it's the reverse operation of our previous unit, exactly. But so there's square roots, though, that I can't dream up a number that's nice. It gives me 7 as the answer, like when you square it. Square root of 7 would be an example of an irrational number, and it doesn't come as a nice package like a fraction. Now, I know I handwrite, but maybe you can bear with me and try this. This is from the textbook. Yeah, this messy old man. Page 97, example 1, but don't worry. I think I'll just do this. You guys know what I'm going to do. You guys jot this down while I type it up. I know. Well, give me time, dear. There we go. Yeah, I got it. I got it. And Papa's taking care of things. Write three rational numbers in between each pair of numbers. Now, I put this number line on here because sometimes it helps some people visualize things. You don't have to. I actually know for pretty much a fact, I think there's some students that would snap, 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 three numbers right away. I'm going to ask some people maybe who maybe don't have it right away, because you know what? That's who I'm trying to help the most. I'm trying to help you all. But 1.8, negative 1.8, negative 1.5. This is why this number line isn't drawn to scale, but I just wanted to emphasize zero. The positives are on the right hand side. I want to emphasize that negative 1.5 is actually bigger than negative 1.8. Sometimes it helps if you think of this as money. That's $1.5, $1.50, and this is just straight name. It's the same number. Let's say $1.80 and $1.50 on the negative side, right? But what are some dollar amounts if you owed money in between those two? That might help you. One negative 155 would be sure. Well, let's write this down here then. Okay, so I'd say that one's close to here, so I'm going to go negative 1.55. Now, it's not that it is money, but it's easier to think of money sometimes in decimal situations. Okay. I could go negative tariff, or someone bad at tariff somewhere else. Something else in between 1.8, negative 1.8, negative. You could just, you didn't have to use $1.50 or negative 155. But anything goes, tell me. Like there's an infinite number of answers. I just need one though. What's that? Negative 1.7. We didn't even need to use the decimal. I put 1.7 over here more. Negative 1.7. Okay? This is what we're asking. Like this is coming up. Oh yeah, that's in between, right? I'm doing the visual. You didn't need the visual if you truly understand this, but it helps. Anything else? Well, yeah, there is, yeah. Negative 1.6. You guys are keeping it easy. Sure, why not? Yeah, I could even go, and I'm not going to keep this, but negative 1.600032844. Like, I'm going to remove those red things. That's also in between there, isn't it? Right? Doesn't matter how many decimal places you have. As long as it's in between negative 1.8 and 1.5. So if you have a question like this, you understand what to do? So E, that was E from example 1. I'm going to move it up. I like to move it. Okay, this time is not decimals. So that means if it's presented in fractions, I want fractions as the answer to the decimal. Between half and 1. And I'm going to give people I haven't heard from. So people think this is tricky. Keep paper here. Or do you have it? Yeah. Okay. So half and 1, and I don't want, I know half is decimal 5, so I could say decimal 75 or decimal 99 or something like this, but I don't want it as decimals. I want it as fractions. Help me out if you haven't helped me out before. Help a brother out, come on. Yeah. Dang it. You helped me out before. But yeah, I'll take your answer. 2/3 is correct. Whereabouts would 2/3 be, guys? Is it closer to the half or is it closer to the 1? 2/3. Yeah. That's great.
2/3, 1/3. If we go from 0 to 1, and break this up into 3 equal parts, we want the second third. So, would you agree that without looking below here, I'll just do this because it might help me. I'm going approximate, but I'm using my fingers here. Would you agree that this is approximately equal? Like this is 3 parts that are approximately equal? The 2 out of 3 will be closer to the half. I only wanted to do this so I knew my number sense here where it would fit. Right? I'm going to just move those pegs here. Now, 2/3 works. Another way I know that 2/3 is closer to half. I know because I work with fractions a lot. The other thing is what's the decimal for 0.5? What's the decimal for half? I said it. It's 0.5. What's the decimal? The repeating decimal for 2/3. You guys know that one? What's that? 6. 3 is the 1/3. Decimal 6 repeating. 666. And 6, we're going to round it to 0.67. It's definitely closer to half than it is decimal 5 than it is. Okay. Something else as a fraction. 12/14. Sure. That's a good one. I'm going to just put it down. And you know what? 12 out of 14 is almost 1, so I'm going to put it on the farther end. It's interesting you gave me this, and I know you know what you're doing. You gave me one that's not reduced. It's the same as 6 out of 7, but I have 12 out of 14. Thank you. And hey, what is exactly in the middle of half and 1? What's that? That's the decimals, yeah. 3/4. Football, right? Divided into 4 quarters. A football game. We're familiar with that. 1/3 quarter is halfway between halftime and full game. I'll use that one. But you know what? I think Charlotte hit on something here by just saying 12 out of 14. Fractions. As long as you know equivalent fractions, right? 1/2. Well, what's that equivalent fraction of 1/2 if I said it's out of 32? What's half of 32, guys? 16. So anything above 16 out of 32 will be, it has to be less than 32 as well, in between half and 1. So 17 out of 32, 19 out of 32. Some of them can be reduced if said 18 out of 32 if it's even. Okay. So it's a very open-ended question when I say it. But you need to know this. And if you know wrenches, you know what I'm talking about, old imperial wrenches, millimeter wrenches, like metric wrenches, are way easier to say which one's bigger or smaller. But if you, anybody do mechanics or use wrenches and know this stuff, you got 8ths, you got quarters, 8ths, then you have your 16ths measurements for wrenches, and 32nds, and even 64ths sometimes.
You know that thing, like, where you move it?
A crescent wrench, a spanner?
No, like, you move it. I can't remember.
Are you talking about tools? We'll have to remember some other time. I probably do. I just don't know what you described. Can you guys do this? Order from greatest, from least to greatest, smallest to biggest. Really, is what that means. I'll pause the video while I retype. Okay, I'm going to assume that most people are almost there by the pen's moving. More than half of you are. Guess what you're going to do? I'd say the best way to do this, if you're not nifty with numbers, stuff like this, is to make decimals out of these. Because you've got calculators, you're allowed to use calculators. I look at this, and I know the smallest and the largest without thinking about fractions. So what's the smallest guaranteed? The negative one. And the largest is the 1 and 3/4, because the other ones aren't improper fraction, where the numerator is bigger than the denominator, where the top's bigger than the bottom. But just because I want to show you a method that works when it's all tricky stuff, Use a calculator and do the division. You might know this though, without using a calculator. So I'm going to do that. First one, 2 out of 3, because we just talked about it. What is that again? Yeah. 2 out of 3 is not, is a decimal. 666 repeated, so I'm going to put 0.67. That's 0.67. Negative 1/2 I know is 0.5. I could use a calculator to do that. And then 1, that means it's 3/4, 1 point. In the 3 out of 4, I think we know 75 cents from $1 and 3/4. So I could do that on the calculator. I didn't. Finally, 7 out of 9. I don't think many people know this one off the top. What is 7 out of 9? I don't remember. I know it's going to be around 0.7. What is it? I need to know. I'm really inquisitive, but I'm too lazy to use my own calculator. Every fraction can be thought of as a division problem. Good question. So 7 divide 9. Thank you. I'm going to get Ronnie to repeat what he gets so I know. 7, the fraction sign is a division sign, then 9. What do you get, Ronnie? A lot of 7s. How many? Yes. Okay, it fills the screen. I'm going to just go 778. You could have said 0.78. I'm rounding. It goes 7 repeating forever. Yes. That's a dumb calculator. We're going to have to figure that out. No. It's useful for something. What I do, and I don't know exactly how to do it, is I put in your model number, Casio 90X or whatever, and then say show decimals or something on Google. And then, I don't remember. Every brand. Now that I can do this one, you guys see how much easier it is to put the numbers from least to greatest? Like I said, this one I actually could have figured it out, but the half was negative, so I never second guessed. 2/3 is 0.67, then the 7 ninths. And the 2/3 and the 7 ninths, actually, you probably need the decimals to figure that out. Yes, there's other ways to do this.
How is 2, 3, like?
I just had a question. I'll show this. I was asking, how's 2 out of 3, 0.67? Because you get 6, 6, 6 repeating. If I tell you to round properly to the hundredths, what does the 6 behind that tell you? Push it up, right? I just did round, just because I didn't want to write forever.
It'll be like 6 and 7 more 6s.
Nope, that means, you know about rounding? Oh, this is why. Yeah, I'm going to take a moment here. If I say round something off, cut it off there. But I can't just say 0.66 and stop. It's actually on the number line closer to 0.67 than it is 0.66. How do you know that? If you look at the digit behind it. Is that number 6 behind it closer, is it higher up than 5 or lower than 5? Is it closer to the next number or stays around the same? So if it's higher, 5 or higher, you push up, all around. Gas prices. You know how gas prices give 3 decimals on the board, like when you see a gas price? Ever notice that? Never. They don't just have $1.67. They have $1.67.9. It's not like those gas prices are round. They're not going to pay a decimal minus. So that's an example of rounding to 2 decimals. That's all this talk, and I haven't had a chance to do any questions. Which part of it, disappointed? Yep, you are. Well, how about this? Right. I want you to try 5 through 10 on page 101.